Metrology is the basic knowledge of accurate measurement. Sometimes we have to apply this knowledge to the situation that requires proof and confirmation that those equipment or tools used in the measurement are accurate and are actually what the manufacturer claims.
Nowadays, people have come to use the UVC light to kill all the germs, especially the COVID virus. Okay, so people come to ask for help. They want to know what intensity of the UVC they have for their equipment and how long they should use to kill the gel. So what we help them is we make a measurement on the UVC intensity in their chamber or their robot, UVC robot. And some people bring the UVC chamber. So for the light in that region, we have to provide the traceability for the scale from 200 to about 400 using this national reference standard lamp. From the scale in the national reference standard lamp, we transfer the scale to our reference spectroradiometer and then to the working radiometer. In addition, we also do the innovation, the so-called do-it-yourself UVGI chamber. Okay, so what we have done is we use the old microwave or broken microwave, remove the microwave tilt and replace it with the UVC lamp. Okay, and we measure the intensity and tell the user how long they should expose their object in that chamber.
This project happened roughly a few months ago. A representative doctor from Thammasat Hospital came to NIMT asking for technical support. The situation was they have a lot of donations and one of the majority of those donations were PPE suits. Some of them is very obvious that they were fake, which basically means they are very poor quality. The dilemma was how are they going to deal with these donations? But we came up with the idea if we could distinguish the good one of the bad ones would be the best solution. The method that NIMT came up with is a non-destructive technique for the PPE suit using air. So we'll start with a PPE standard that doctors typically use. Main two parameters in this study are pressure and flow rate. We are going to fill the PPE suit with air and study those two parameters. The initial assumption are the bad one will have less pressure and more flow rate. Lastly, when this project has been finished, we can do a technology transfer. We could distribute this prototype of verification kit to hospitals that they have the problem of fake PPE for them to check before use to increase their confidence level of their armor before they entering the battlefield of COVID-19. A ventilator tester is a standard equipment to verify functionality of ventilator machine used in hospitals. Therefore, to ensure its accuracy is very crucial. This activity is to calibrate the ventilator tester in the aspect of pressure and flow with NIMT standards, which be able to trace back to SI unit. After calibration, the tester will be used to test ventilator machines in hospitals, as I stated earlier. With a good quality equipment, it will increase confidence of its user, such as nurses, doctors, which finally use or provides safety and effective remedy for patients.
As the situation of COVID-19, clinical thermometers are widely used to screen people. These thermometers, including ear infrared thermometer and skin infrared thermometer, are routine used for the screen. At the National Metrology Institute, we provide the testability of the temperature measurement for the clinical thermometer. This includes design and manufacture the standard equipment. So we use metrology to improve health and better life.
So as we all know now that our world has faced a problem with the COVID-19 pandemic, in terms of bioanalysis group, we are now participate participate the inter-laboratory comparisons with NIMS around the world to make sure that we will have standard method for measuring COVID-19. The technique that we are using will be RT-PCR. We expect that the digital PCR can be harnessed to provide confidence in the value assignment of the variety of reference materials. We expect to have an evidence for calibration measurement capability claim for RNA copy number concentration in vitro synthesis. Also, we expect that we will be able to show our country's ability for measuring SARS-CoV-2 with reliable data in order to support of global SARS-CoV-2 diagnostic.
I have developed the measurement of PM2.5 by using the gravimetric method. The method is compliant to the EPA and this is a primary method. NIMT conduct the inter-laboratory comparison of the PM2.5 monitor. This project is collaborate with the pollution control department. The objective of the project is to verify the accuracy of the PM2.5 low-cost sensor. The impact of this project is to provide the accurate results of PM2.5 data. The low-cost PM2.5 monitors give the accurate and results and reliable. Therefore, the environment will be better and people will live more safely.
So if we think about the technology today, all the technology rely on the measurement and the precision measurement is come from sensor. Nowadays sensor has reached limit. So that means the classical sensor can measure the precision, just only this precision. To overcome this precision, we have to go through the boundary from classical to quantum. So the next generation of the sensor must be the quantum sensor. In NIMT, we try to develop the quantum metrology. The first project that we try to do is we do the optical clock. So in this project, we would like to have the atomic clock that has limit down to 10 to minus 18. So this 10 to minus 18 can open the technology in the future. For example, you have to make a spacecraft that can navigate itself in the deep space. To navigate the spacecraft in the deep space, you need to rely on the very precise sensor. One of them is atomic clock.
In addition, we have communicated with the public sector by using the metrological knowledge to create innovative models based on its application to support various sectors. If we apply the measurement capabilities to the situation, this is to raise the standard system, which is an important foundation to support the national quality infrastructure.